This is the full class video for Honors Algebra 1, Section 9.4. Today's big concept is the zero product property. Let me illustrate the zero product property for you. Most basic way of looking at it would be to say if A times B is equal to 0, if that's true, then either A equals 0 or B equals 0. This is a very special property of 0. We looked at this back in, I guess it would have been chapter 2. Basically, the property is anything times 0 is 0. And so the fact that this is A times B equals 0 is really important. The 0 doesn't stand for just some number. It's exactly 0. That's why it's called zero product property. The other thing to look at here is the word product. Word product, of course, means multiplication. And so we're looking at a very specific situation. If you have one factor times another factor, and the product is 0, then either the first factor is 0 or the second factor is 0, or really both could be 0. So we're going to use this zero product property to help us solve a couple of pretty simple equations. So take a look at number 1. Number 1 says solve for x, and then we've got x plus 6 times x minus 8 is equal to 0. So notice that this right here, this is a product. The reason that we know that that's a product is because we've got one factor times another factor. It's not plus, it's not minus, it's times. So you got to recognize that first. So we've got a product, and notice that the product is equal to 0. So the way that we would solve this, I want to see all these steps when you work through these, is we would set each factor equal to 0. X plus 6 is equal to 0. X minus 8 is equal to 0. And now we just use our old problem-solving skills to solve. So we're going to subtract 6, so x is equal to negative 6. And we will add 8 to both sides, so x is equal to positive 8. So this equation actually has two different answers. You can certainly go back and check by plugging in. If I were to plug in the negative 6, I'd get negative 6 plus 6 times negative 6 minus 8 is equal to 0. And of course, negative 6 plus 6 is 0. So it would be 0 times negative 14 is equal to 0. And of course, that checks. Okay, so at any time, feel free to pause the video and try. This next one is certainly similar to what we just did. Okay, please, first of all, notice that the left side here is a product. It's something times something else. So we have a product. And notice that that product is equal to 0. So since we have this situation, we can use the zero product property. Zero product property says that if you have two factors multiplied together and the product is 0, then either one of the two factors or both would be 0. Here's what we do. We're going to set each factor equal to 0. So 2x minus 9 equals 0. 3x plus 7 is equal to 0. And now we solve. Solving here is a little bit harder, not much. We're going to add 9 to both sides. So we're going to get 2x equals 9. And we divide by 2 on both sides. So x is equal to 9 over 2. And then on the right side here, we're going to subtract 7. So we get 3x is equal to 0 minus 7, which is negative 7. And then divide by 3. X is equal to negative 7/3. So once again, we've come up with two different answers. Either of which should check just fine. Feel free to do that as needed. All right, number 3. Again, feel free to pause the video, try a problem like number 3 on your own, start the video back up and see how you did. All right, again, please notice that we have a product. So the product is equal to 0. So once again, we can use the zero product property. These two recognition pieces of recognizing a product equal to 0 are very important because later on that's going to change. Okay, so what we do now is we set each factor equal to 0 using the zero product property. So x is equal to 0. There's my first factor. There's my second one. 4x minus 9 is equal to 0. Of course, that's already done. over here on the right, we just need to solve using our old problem-solving skills. So we go plus 9 to both sides. 4x is equal to 9. Divide both sides by 4. We end up with x is equal to 9/4. So we have two answers. One of them is 0. The other one is 9/4. Sometimes people will, discount the 0 and say, oh, that's not really an answer. 0 is an answer. 0 is a number. And so that is one of the two answers. Okay, so moving on, let's take a look at number 4. All right, notice, same pattern, we got equals 0, but on the right, please notice we don't have a product. Notice how it is something plus something. That's what's going on the left side there. That's a really important difference. So we cannot say 2x squared equals 0, 8x equals 0. We cannot do that. I'm going to get rid of that. We cannot use the zero product property until we have a product equal to 0. And the truth is, this is not a product. So what we need to try to do is we need to try to create a product. And I'm going to show you how to do this. And then I'm going to explain some of the details, and we'll come back around to it. So the way that we create a product is we need to use, we can refer to this in a couple different ways. What we're technically going to be doing is we're going to be creating factors. We're going to factor this. But for a lot of folks, it's easier to think of this, at least first off, as the undistributive property. We're going to try to reverse the distributive property. So here's how you do that. Let's pretend that the distributive property has been done to the left side, and we're going to try to pull that factor back out. So please notice that between the 2 and the 8, there's a common factor of 2. So I'm going to undistribute that. Also, please notice that between the variables, the x squared and the x, there's a common x. And so with the distributive property, of course, there's always parentheses. So I'm going to write what's left over, like what would have been distributed into. So I had a 2x squared for that first term, and notice I pulled out the 2 and an x. So what's left over here is simply just an x. Now I had an 8x for my second term, so it's going to be plus. Well, I pulled a 2 from the 8. I undistributed it, so 8 divided by 2 is 4. I had an x, but I brought it out. So I've undistributed the 2x. And notice what I've done. I've gone from something that wasn't a product to something that is a product. So what I can do now is I can set each factor equal to 0 using the product as the zero product property. So I'd say 2x equals 0, x plus 4 equals 0. I'd then divide by 2 and get 0, and then subtract 4 from both sides. My other answer would be x equals -4. Now, if you didn't quite pick that up, that's okay. We'll come back to it. I want to talk to you a little bit more about factoring. So let's talk about what factoring the greatest common factor actually is. Like I said before, I like to think of it as the undistributive property. That's not really an official math term, or you could think of it as the reverse distributive property. Something like that. So I want to illustrate this for you. So take a look here at our first one. Do you guys see in A that the distributive property could be done? So what I'm going to do is I'm going to do the distributive property. I'm going to write it down as 5x times x minus 5x times 4. So do you notice how that 5x has been distributed? Then multiplied in there. Now normally what we would do is we'd probably just immediately write 5x squared minus 20x, right? I mean, you guys know what 5 times 4 is, and x times x is x squared. And it's not that complicated, but I wanted to show you this step so you could see what I'm going to do next. If I started here and I was going to factor, what I would do is I would say, well, what's in common? What's the greatest common factor? Well, there's a 5. And there's a 20. The greatest common factor is 5. And there's an x squared and an x, so the greatest common factor, what they both have an x, right? I mean, this first term has an extra x, but they both have at least an x. So I could rewrite it like this. Now that I recognize that both terms have a 5x, I can undistribute it. So I'm going to reverse the little rainbow thing. I'm going to pull these out, right? Put the parentheses back in, and I'm left with x minus 4. So we're just talking about reversing the distributive property. Why this is important is we want to be able to create factors so we can use the zero product property. Okay, so same idea. If I were to distribute, I would get 6x cubed y plus 21x squared y squared. And you might look at this, and the instructions might be to factor. So what we need to do is recognize what is in common. That's why it's called the greatest common factor. Sometimes greatest is confusing. People see greatest and they think really big. But actually, the greatest common factor will be no bigger than the biggest factor. It's actually typically going to be smaller than the biggest factor, the biggest term. Okay, so taking a look at the 6 and the 21, the common factor is 3. Taking a look at the x cubed and the x squared, well, they both have x's. The first term has 3 of them, the second term has 2 of them, so what's in common would be 2 of them. They both have 2 of them. The first one has an extra one, but they both have 2. So x squared. And then taking a look at the y's, the first term has 1y, the second term has 2 of them, so what's in common is just the 1y. So you could rewrite this like so. And now you can see that both terms have a common factor of 3x squared y. So what I'm going to do is I'm going to undistribute that. I'm going to bring that back out. So I get 3x squared y, put the parentheses back in, 2x plus 7y. Okay, so just think of factoring the greatest common factor as reversing the distributive property. It's really what it is. So let's see if we can practice this in problems like 5, 6, and 7. So feel free, if you want, to pause the video and try these. They're of varying difficulty. You can obviously restart the video and watch, see how you did. Okay, number 5. I've got a 12 and a 42. We need to think, what number is the biggest number that goes into both 12 and 42? What's the common factor? So I know that 12 is 6 times 2. Is there a way to think of 42 as 6 times something? Well, sure, it's 6 times 7. So I'm going to rewrite this as 6 times 2x plus 6 times 7y. I haven't changed anything, I've just rewritten the form. I've attempted to factor the greatest common factor. Please notice that the first term has a 6 and the second term has a 6. And in this case, that's the only common factor. So if I'm going to factor out the greatest common factor, I have 6. I put the parentheses back in, 2x plus 7y. How could you check something like this? Well, if you just distributed the 6 back in, shouldn't you end up with what you started with? Of course. If it's the undistributive property, it should work that way. Okay, let's take a look at number 6. Got 3 terms this time. So I've got an 18, a negative 12, and a 24. What's the common factor there? What's the biggest number that goes into all 3? Well, once again, it's a 6. So I'm going to write a 6 here. Well, I'll leave that alone. I'm going to get rid of the parentheses for a second here because we got more than just a 6. Take a look at your x's. I've got an x squared, I've got an x, and I've got an x. What do all 3 terms have? Well, we've got 2 x's in the first, 1 x in the second, and 1 x in the third. So they all have an x. It's true that the first term has an extra x, but it does have an x, and so that's what's in common. I think we'll find the same pattern with the y's. First term has 1, second term has 1, third term has 2, so they all have 1. So my greatest common factor is 6xy. So I'm going to rewrite it as 6xy, and then let's see here. What I have left over in the first term would be a 3, and then there's that extra x. And in the second term, I've got 6xy times, well, I've got a 2 from the 12, but that's it. There's no extra x's or y's. Plus, the last term I have an extra 4 because 24 divided by 6 is 4. And then I've got an extra y because of the y squared. So my final step would just be to undistribute all three of these. So it would be 6xy, put the parentheses back in, 3x minus 2 plus 4y. At this point, what I've done is I've factored. I've created a product where before I didn't have a product. Okay, our last one, number 7. Again, if you haven't paused the video and tried these on your own yet, number 7 would be a good one for you to do that on. Okay, so looking at the 4 and the 24. The greatest common factor with 4 and 24. What's the biggest number that goes into both? Well, it's going to be a 4, right? Because 4 goes into 4 and 4 goes into 24. And then looking at the x's, I've got x to the 4th and x cubed. What do they both have? The first term has x to the 4th. The second term has x to the 3. So they both have at least x to the 3. So I'm going to rewrite this as 4x cubed times x minus 4x cubed times 6. Just rewriting it. I haven't changed anything. Of course, if I just multiplied these two terms, back together, put everything back together, I'd have what I started with. What I'm going to do now is I'm going to undistribute. I'm going to bring this out. It's going to be 4x cubed, put the parentheses for the distributive property back in, x minus 6. Once again, I've created a product where I did not have a product before. Okay, we're going to try to use this some more. For example, number 8. Okay, so please notice, we're still using the same skill. We're still trying to use the zero product property. Notice that the left side is not a product, but the right side is 0. So that's good, but the left side not being a product, that's a problem we need to fix. So let's see if we can fix this. What's in common between the 6 and the 15? It's the biggest number that goes into both. Well, yeah, this time it's just a 3. All right, and then between the n squared and the n, what's in common? Well, they both have an n. So you can do this step. You don't have to do this step if you're getting good at this, but I'm going to rewrite the first term as 3n times 2n, right? Because that's 6n squared is 3n times 2n. The second term I'm going to rewrite as 3n times 5. Okay, now we're going to see what's in common, of course. They both have a 3n. So I'm going to undistribute the 3n. So it's going to be 3n, put the parentheses in for the distributive property, 2n minus 5 is equal to 0. Now I want to be really clear. This step right here, you do not have to show that step. If you can go from here to here, that's fine. Totally fine. I just show you that in-between step right there. If you're struggling, you can kind of see where things are coming from and where they're going and all that stuff. All right, now I've got a product on the left side, so I can use the zero product property. So I'm going to write this as 3n equals 0 and 2n minus 5 equals 0. Just using the zero product property, which says that if you have a product of 0, then either of the two factors should be or could be 0. Okay, divide by 3, n equals 0. Over here, I'm going to add 5 and divide by 2, so I get n is equal to positive 5 halves, 2 answers. All right, last regular example, then we'll do a few applications. Number 9. Please notice that with number 9, well, for the first time, we don't have equals 0. That's a really important thing because it's called the zero product property. So kind of our home base, our starting line will be equals 0. So what I'm going to do is I'm going to subtract 9x from both sides. What that'll give me is 3x squared minus 9x is equal to 0. And that's where I want to start. I always want to start off with something or other equals 0. If I don't have that equals 0, I'm going to have some trouble for sure. Okay, so please notice the left side is not a product. You knew that was coming, of course. And so we need to create a product. And the way we create a product is to factor out the greatest common factor. So I'm not going to show you the in-between step on this one. We're just going to look and say, well, the common factor between 3 and 9, the biggest number that goes into both is a 3, right? 3 goes into 3, 3 goes into 9. It works. And with the x squareds, what's in common? Well, they both have at least an x, don't they? I mean, the first term true has an extra, but they both have at least an x. So 3x is my greatest common factor. The distributive property always uses parentheses. What I'm going to write here is what's left over. So in the first term, I had a 3x squared, and I took out a 3, so that's gone. I took out one of the x's, so the only thing that's left in that first term is just a single x. Minus, I had a 9, but I factored out a 3. So what's left over is a 3. And I did have an x, but I took it out. So I undistributed it, so it's gone. What I have left over is a beautiful product equals 0. So I'm going to use the 0 product property. 3x equals 0, x minus 3 equals 0. So my final steps would be to divide by 3 and get x is equal to 0. And over here, add 3 to both sides, and get x is equal to positive 3. All right. Last couple of problems here. Okay, these are both going to involve what's called so this vertical motion model is going to be something that I'll supply to you, but you're going to need to know what each of the pieces mean. So let's talk about what they mean. We're talking about vertical motions. We're talking about something being thrown or launched or thrown off of a building or thrown up to the top of a building or something like that. So h is going to stand for the height at some particular time. The t is going to stand for time. The v is going to stand for the beginning. I'll put BEG for beginning velocity. The t still stands for time, and the s stands for the beginning height. So yeah, these are the meanings of these symbols will be something you're going to have to remember, and we'll talk about this quite a few times, but make the effort right now to remember, and I think it's common sense, T for time, H for height. The S for beginning height is a little bit weird. You can think of it as starting height if you want. S, starting, right? And then the beginning velocity, V, velocity. There you go. Okay, so let's take a look at number 10. It says a model rocket is launched from the ground with an initial vertical velocity of 48 feet per second. After how many seconds will it hit the ground? So I'm going to fill in everything that I know. First of all, I know that h is my height at any time. I don't know that yet. I don't know anything about time. In fact, doesn't it say after how many seconds? Kind of sounds like t is just going to be my variable. So t squared. V is my beginning velocity, and the word initial does mean beginning. It's 48, so plus 48t. And then my beginning height, well, it says it's launched, this rocket is launched from the ground. So the ground has a height of 0, right? So I could put plus 0. I'm not going to bother. Okay, so what this stands for right here, this equation, is the vertical motion model for this particular rocket. So I could plug in any particular time, 1 second, half a second, maybe 3 seconds, and I can know the height at that particular time. Okay, so anyhow, the question says, after how many seconds will it hit the ground? So we're talking about the rocket, and we already talked about earlier how the ground has a height of 0. So if the ground has a height of 0, when the rocket will hit the ground is the question. Really what we're saying is, when will the rocket have a height of 0? So I'm not going to plug a 0 in for time. I'm going to plug a 0 in for h. And hopefully this looks pretty familiar. Because doesn't that look a lot like what we've been doing? Check out, say for instance number 9. We got to this step right here. That should look a lot like this. Okay, so we're going to practice factoring out the greatest common factor. And strongly suggest you pause the video, try this on your own, and see how you do. All right, here we go. So on the right side, the greatest common factor between negative 16 and 48 is negative 16. The common factor between t squared and t is just a t. We'll write our parentheses to write what's left over. And what's left over in the first term is a 3t. Excuse me, it's not a 3t, it's just a t. And what we have left over in the second term is a 3. So t plus 3. Now we can use the zero product property to figure out our time. And when we solve, we come up with t is equal to 0 or t is equal to, oh, hang on, I factored wrong. This middle term should end up being t minus 3. The reason for that is we factored out a negative. If we factor a negative out of a positive, we're essentially dividing that positive by the negative, and so we'll end up with a negative 3 here. So it should be t minus 3 equals 0. So we end up with t equals 0, t equals 3. So as far as when the rocket will hit the ground, the answer to that is going to be t equals 3. We know that at t equals 0, the rocket was on the ground. That's where it was launched from. And so the second time will be the time when it actually hits the ground. So if you were to sketch out a picture, rocket starts here, goes up, comes back down. It took 3 seconds for it to do that. All right, last one. This one says a golf ball is hit from the ground. There's a key phrase that's shared with the previous one. With an initial vertical velocity of 32 feet per second. Again, key phrase. So I'd suggest you pause the video and take a second, see if you can do A. Write a vertical motion model for the golf ball. Okay, so your vertical motion model is h is equal to negative 16t squared plus vt plus s. And we know that there was an initial vertical velocity of 32 feet per second. So we're going to put 32 in there for v. We also know the ball was hit from the ground. That means the starting height is 0. So in place of s, we could put a plus 0, or we could just leave that off. What this is the vertical motion model for the golf ball at any particular time. So part B says, after how many seconds will the ball hit the ground? So if the ball is going to hit the ground, it means it's going to have a height of 0. And so in place of h, we're going to put 0. All right, so what we have here is we've got equals 0, and we'd like to use the zero product property, except the right side's not a product. And so we need to create a product by factoring. So let's take a look carefully what's in common. Between the negative 16 and the 32, I'm going to factor out, like we did before, I'm going to factor out a negative 16. What's in common between the t squared and the t is a t. Put in the parentheses for the distributive property, and we're going to write what's left over. In the first term, the only thing left is a t. And remember from last time, if you have a positive and you factor out a negative, you're left over with a negative, because a negative times a negative is a positive. I had a 32, brought it to 16, so what's left over is a 2. All right, so now we can use the zero product property. I'm going to set each factor equal to 0. So negative 16t is equal to 0, and t minus 2 is equal to 0. Come over here and solve. I'm going to get t is equal to 0 from this left side, and I'm going to get t is equal to 2 from this right side. So after how many seconds will the ball hit the ground? Well, t equals 0. That's when the ball started on the ground. T equals 2 seconds. That's when the ball actually comes back down and hits the ground. All right. Hope this went well for you. Good luck. See you in class next time.